Nuclear energy is a form of energy released from the nucleus, the core of atoms made of protons and neutrons. This source of energy can be produced in two ways: fission, when nuclei of atoms split into several parts, or fusion, when nuclei fuse together.
The nuclear energy harnessed around the world today to produce electricity is through nuclear fission. Generating electricity with nuclear fission is still in the research and development stage.
Inside nuclear power plants, nuclear reactors and their equipment contain and control the chain reactions. It is most commonly fueled by uranium-235 to produce heat through fission.
The heat warms the reactor's cooling agent, usually water, to produce steam. The steam is then channeled through to the spin turbines, activated an electrical generator to produce electricity.
Nuclear fission is a reaction where the nucleus of an atom splits into two or more smaller nuclei, releasing energy.
When hit by a neutron, the nucleus of a uranium-235 atom splits into a barium nucleus, a krypton nucleus, and 2 or 3 neutrons. These extra neutrons will hit each other surrounding uranium-235 atoms, which will also split and generate additional neutrons in a multiplying effect, thus generating a chain reaction in a fraction of a second.
Each time the reaction occurs, there is a release of energy in the form of heat and radiation. The heat can be converted into electricity in a nuclear power plant, much like how you produce electricity from fossil fuels. The nuclear fuel cycle.
The nuclear fuel cycle is an industrial process to produce electricity from uranium and nuclear power reactors. The cycle starts with the mining of uranium and ends with the disposal of fuel, spent fuel, and other radioactive waste. What is nuclear energy used for? Nuclear energy produces electricity that can be used to power homes, schools, businesses, hospitals, etc.
How efficient is nuclear energy? Nuclear plants are the most efficient source of electricity, operating 24/7 and at 93% average capacity factor. Capacity factor is the ratio of the actual amount of electricity generated by a plant compared to the maximum amount that it could potentially generate. That's more than 2 times the capacity factor of any other carbon-free source.
Advantages of nuclear energy. Nuclear energy is one of the most low carbon energy sources. It has one of the smallest carbon footprint. It's one of the answers to the energy gap. It is essential to our response to climate change and greenhouse gas emissions. Nuclear energy is reliable and cost effective, and it produces low pollution.
Disadvantages of nuclear energy. Nuclear energy is expensive to build, despite being relatively inexpensive to operate. Nuclear power plants are incredibly expensive and the cost keeps rising. Human error produces highly radioactive waste that lasts tens of thousands of years. Security threat and limited fuel supply.
Sustainability of nuclear energy. Nuclear energy is a zero-emission clean energy source. According to the Nuclear Energy Institute, or NI, the United States avoided more than 476 million metric tons of carbon dioxide emissions in 2019 due to nuclear energy.